On the following video, I'll be showing you how to simplify algebraic expressions. So first I want to start by defining what an algebraic expression is. So an algebraic expression is a mathematical statement or a sentence that includes the following. So it has variables. And of course, these variables can have exponents. So along with variables, you also have numbers. And there's two types of numbers. You have coefficients. And coefficients are numbers in front of the variable. So numbers being multiplied by the variable. You also have numbers that are considered constants. Constants are numbers without a variable. And the last thing, you have operations. Remember, operations are addition, subtraction, multiplication, and division. So let me give you some few examples of algebraic expressions, and then we will name them. So the first example. Second example. And our third example. So our first example is 5x. That is one term, so you call that a monomial. And obviously the prefix mono means one. So that is an expression with one term, a monomial. Our second expression has two terms, so you call that a binomial. And of course, the prefix bi means two. Our third expression has 1, 2, 3 terms. You call that a trinomial. And again, the prefix tri means three. So an algebraic expression with two or more terms can also be called a polynomial. And the prefix poly means many. So remember, a polynomial is an expression with two or more terms. So technically, binomials and trinomials are also considered polynomials. Okay, so let's simplify the following algebraic expressions. On this problem, to simplify, all you have to do is combine the like terms. So first, let's identify our like terms. Our like terms are 15x and 3x. And both of those are like terms because they both have an x next to them. So 15x minus 3x gives you 12x. And then the constants, -7 minus 6. Both of those are like terms because they are constants. They don't have variables next to them. So -7 minus 6 gives you -13. And you are done simplifying because you no longer have like terms. Notice that the first term has an x. The second term is just a constant. Those two are not like terms, so you are done. On example 2, we are also simplifying, but I have added one more step. We are doing what's called the distributive property. So the distributive property, all it tells you to do is to multiply. So let's multiply whatever's in front of the parenthesis. So we're going to start by distributing a -5 to everything inside the parenthesis. So -5 times 2x gives you -10x. -5 times -10 gives you +50. Right here, all you see is a minus, but that's really a -1. So we're going to distribute a -1. So -1 times 5x is -5x. -1 times +3 is -3. So we've applied the distributive property. Now let's combine our like terms. -10 minus 5x is -15x. 50 minus 3, those are like terms because they're constants, numbers without variables. So 50 minus 3 is 47. You don't have any more like terms, so you are done. So try the following problem. Pause the video. Okay, now let's simplify. So we're going to distribute the number in front of the parenthesis. And remember, distributive property is basically multiplication. 5 times a is 5a. 5 times negative b is negative 5b. So on the second part, we're going to distribute a negative 6. Negative 6 times a is negative 6a. Negative 6 times b is negative 6b. So let's combine our like terms. So let's first identify them. So like terms are 5a and 6a. And then our second pair of like terms are negative 5b and negative 6b. Okay, so let's do the 5a minus 6a. So 5a minus 6a is negative 1a. Negative 5b minus 6b gives you negative 11b. And we are done simplifying because we do not have any more like terms. This has an a, this has a b. You cannot combine those, so you are finished. Okay, so let's simplify problems that have exponents now. So we are still simplifying, so let's distribute. So I see a negative here, but technically that's a negative 1. So let's distribute the negative 1 into everything inside the parenthesis. Negative 1 times 3x squared is negative 3x squared. Negative 1 times negative 21x is positive 21x. Negative 1 times 6 is negative 6. So we're done with that part. On the second part, we're going to distribute a negative 4. Negative 4 times negative x squared is positive 4x squared. Negative 4 times 6x is negative 24x. Negative 4 times negative 4 is positive 16. So let's combine our like terms. Let's start with the variables with the highest exponent. So these are the squares. So let's combine these two. Negative 3x squared plus 4x squared gives you 1x squared. Our next set of like terms, positive 21x minus 24x. So 21x minus 24x is negative 3x. And then our constants, negative 6 plus 16. So if you combine those, you get 10. And you are done because you no longer have like terms. Notice that this is x to the second power. This is negative 3x, and technically this is to the first power. And then you have your constant. So no more like terms. So you are done. Okay, another problem. So let's simplify, and let's start by applying the distributive property. 2 times 3m squared gives you 6m squared. 2 times 6mn gives you 12mn. 2 times negative 7n squared gives you negative 14n squared. You see a minus here, but in reality that's a negative 1. So let's distribute that. Negative 1 times negative m squared gives you positive 1m squared. Negative 1 times 5mn gives you negative 5mn. And then negative 1 times negative 2n squared gives you positive 2n squared. So let's combine our like terms. 6m squared plus 1m squared gives you 7m squared. 12mn minus 5mn. So 12 minus 5 is 7. Don't forget the mn. And then negative 14n squared plus 2n squared. Negative 14 plus 2 is negative 12. Don't forget the n squared. You don't have any more like terms, so you are done. Okay, so on this problem, it's an application problem. So given the following rectangle, so let's look at the dimensions. The length is 4m squared plus 6mn, and our width, that's 6mn minus 3m squared. So let's write an expression that represents the perimeter. So remember, perimeter is the distance all the way around the shape. So we're going to add all these side measurements. So keep in mind that if this is 4m squared plus 6mn, this is also 4m squared plus 6mn. And if your width is 6mn minus 3m squared, this will be the same distance here. So instead of adding every single side out, so let me show you the long way first. So instead of doing this, so that's this side plus this length plus this width plus this width. Let me show you the shortcut. So that takes too much time, too much space. So again, you have two lengths. So let's just multiply this length by 2. And yes, I did not mean to erase that. So I still have it here at the top. So it'll be 2 times 4m squared plus 6mn. And again, I'm multiplying it by 2 because you have two lengths in a rectangle. And now I'm going to add 2 times, and I'm going to put the width, since the rectangle has 2 widths. So what I've done is I've created an algebraic expression, and we are going to distribute and combine like terms, and it'll give us the perimeter of this rectangle. So 2 times 4m squared, that gives you 8m squared. 2 times 6mn gives you 12mn. Now you're going to distribute a positive 2. And again, I didn't mean to erase that. 2 times 6mn is 12mn. And 2 times negative 3m squared, that gives you negative 6m squared. So let's combine our like terms. 8m squared minus 6m squared, that gives you 2m squared. 12mn plus 12mn, that gives you 14mn. So this right here, this expression represents the perimeter of the rectangle, and you are done because you no longer